Nice to meet you. We're Group 9. We are here to present our ACDT project, which explores whether gender actually affects math performance, a question many people have wondered about. Many believe men excel in math and science while women do in language and emotion. These stereotypes affect education and careers. So we analyze data to test if men are better at math is actually true. At first, we explore several familiar questions like whether middle-aged people shop online more or whether MBTI types differ in procrastination. But most of these topics were either too vague and lacked measurable data, so we switched to a clearer and more testable topic: are men better at math? Following our professor's advice, we briefly explored other areas like driving and leadership using t-test and ANOVA. However, since the scope became too broad and we refocused on gender and math performance for a more rigorous, controlled analysis. After more feedback, we narrowed our focus to math subdomains like algebra and geometry, controlling for socioeconomic and psychological factors. Though data collection was difficult, we used two datasets: Kaggle Students' Performance and TIMSS 2019 Korean 8th Graders. We analyzed the two datasets separately. After controlling for background, confidence, and anxiety, the gender gap disappeared, showing that math performance differences come from social and psychological factors, not gender.
We analyzed the effect of gender on math score using linear regression. Men score about 5 points higher, a statistically significant but weak effect. Thus, gender explains little, while factors like environment, background, and motivation more matter. This graph showed that learning environments strongly affect math score. Students with test prep and higher economic background score much higher. Does environment matter more than gender in math achievement? The violin plot showed how parents' education level relate to students' math score. As parent education increases, students tend to achieve higher score, suggesting the social background, especially parents' education, has a higher impact on math performance than gender.
We analyze math score distribution by gender across algebra, geometry, number, and reasoning. Overall, scores are balanced between males and females, but geometry shows more low scores, making its distribution slightly skewed. Here, we examine the distribution of math score across different sections. As shown in the histogram, most of the data follows a smooth, bell-shaped curve, which supports the normality assumption for regression analysis. However, in the geometric section, we can see many low scores, which cause a slightly skewed distribution compared to the other. The graph shows effective site for math solve area by gender. All values are near 0 and below 0.2, indicating minimal gender differences. Thus, gender has little impact on math achievement. These slides show math performance by age and gender. Males average 601.7 and females 609.4. Although the p-value indicates a significant difference, the age trends are similar and female score only slightly higher. Due to uneven age distribution, results should be interpreted cautiously. This slide compares gender myth and reality in math. Females score slightly higher with a small but significant difference. However, the effect size is minimal, showing that real math ability is nearly the same between genders.
This is our system map A. Map A visualizes regression results showing only variables that are statistically significant predictors of math scores, with gender as the main independent variable alongside factors like study hours, parental education, income, and extracurriculars. And this is our system map B. Map B takes a theoretical and scenario-based approach, including hidden factors that may not be statistically significant but still influence learning. It explains the overall education system through interactions and feedback, emphasizing that factors like feedback, confidence, anxiety, and participation also play important roles. Many still believe men are naturally better at math, but data shows otherwise. The gender effect is small and fades when external factors are considered. Math ability depends on environment, not biology, so improving learning conditions matters most. From a system thinking view, math achievement results from interacting social and psychological factors. A reinforcing loop strengthens advantages for students with more resources, while a balancing loop links anxiety, low confidence, and poor performance in a limiting cycle. So what can we do? We should focus on equal learning environments, not gender comparisons. By building confidence and reducing anxiety, we can help students perform better. Ultimately, math ability depends on support, motivation, and emotional stability, not gender.
Through this project, we experienced the true value of data-driven decision-making. Instead of relying on intuition or stereotypes, we learned how analyzing data and interpreting statistical evidence can lead to more objective conclusions. By building and refining regression models step by step, we developed a deeper understanding of how statistical thinking helps us reason logically and interrupt relations systematically. We also realized that research is not about proving one correct answer, but about exploring evidence and understanding patterns. In the future, we plan to extend our analysis beyond gender by including school-level factors, such as teacher feedback, classroom atmosphere, and participation, to explore how individual and environmental elements interact to shape academic achievement in a more structured way. Thank you for listening.